Okay, so in today's simulation, we're going to talk about wave interference. We've already pulled up our lab sheet so that we can answer these questions. You needed to make a copy of it for yourself. Let's go ahead and get started with it. Today, you'll use the wave interference FET simulation and explore how the characteristics of water waves and how they interact. All right. So open the wave interference FET simulation. All right, we already have that embedded in our lesson. So if you're on wave 6, wave interference, it's embedded in the lesson for you there. On the first tab, what can you change about the simulation? So this question is asking you to describe what you see. So we're going to go to the first tab. What can we change? Well, we can change the frequency. We can change the amplitude. So let's go back to water. If I change the frequency to max from min, what's going to happen? You get more drips, right? More drips per second, more. Okay. I can change the amplitude. Check out what happens with amplitude. My drip gets bigger, right? Watch that. See? Little teeny drip. Okay, what other things can I change? Let's see. That's water. I could make it sound waves. Okay. I could make it a light beam or a flashlight, a light. I can put on a graph. I can put on a screen to see what it looks like. That one's kind of fun because it shows particles in the sound one, and you can see how the particles crash into each other and then rarefact from each other. All right, let's go back. So you should answer something in number 1. Okay. So we kind of already started looking at number 2, but start with 1 drip and change the frequency and amplitude. First, predict what you think will happen, and then record what happens below. So what do you think will happen for changing frequency? What do you think will happen for changing amplitude? Type something in the box. All right, and then let's go play with this. It says 1 drip, so we want the water because the water is the one that's going to drip. I'm going to go 1 drip. And if we drip it, okay, but what about if I change the, well, I guess I said frequency first. If I change the frequency, so I'll keep the amplitude the same with 1 drip. All right. This is going to measure the wavelength of the wave. So if I put it right here at the beginning, see how long does it take until it comes back up. Okay, right there. So the frequency, what do I change this frequency? Notice that ripple comes before it did on a low frequency. Okay, so the ripple comes before it did on a high frequency. The ripple comes faster, comes before it did on the low frequency. All right, let's look at amplitude. I guess we could have left that there. If we drip, Now, if we make our amplitude really big, there's a more intense color change there, which would mean a bigger wave. Okay. All right. Let's look at that graph real quick. Notice the crest of the trough moving. Let's look at that amplitude again with the low amplitude. So low amplitude, this is what we look like. High amplitude. So we can see that wave much better with the high amplitude. All right. Then we're going to go 2 drips. So we're just kind of investigating this for a first on this. We're going to go 2 drips. No, wait. Make sure we're in the right place. Try 2 drips and repeat number 2. Okay. So in this one, it wants us to go, if we scroll down a little bit to interference, it wants us to actually go to the interference tab where we get 2 drips. I had been playing with that earlier, so. Let's see, let's go to low frequency and low amplitude. We increase the frequency, we might see a little something. What would we need to change in order to see those waves on the screen better? Somebody whispered amplitude, right? So if we make the amplitude bigger, we can definitely see that variation. We can see the change in the surface of the water much better. So I've got my measurement tools right here where you can see the graph kind of in places where there's no interference. And as you watch the wave, they're lining up, they're doing exactly what they're supposed to do. What happens if I move my measurement tool into a place of interference? And it's kind of hard to see. Let me maybe change the darker one so you can see it better. Notice I move the darker line into a place of interference and we get almost a straight line. So is that constructive or destructive interference? It's destructive interference, right? Let's put our measurement tool closer and see what happens. So where the waves are lining up together, what kind of interference do we get? Constructive. We're building a much bigger wave. And you can see that in the ripples of water. All right. So, and that's what we were talking about when we were using that tool. If we put them close together, we're going to see nice waves. We put them on the interference line, we're going to see either the destructive, what we see right now, or the constructive wave. Notice this difference right here too. I have wave 1 from this water spout, and that's this gray line you can see now. I have wave 2, and then when they come together, they are constructing a much bigger wave, so building up that much bigger wave. So there's some things to put there. Okay, so this is based on your observations. Summarize what happens when you change the frequency, amplitude, and spacing with 1 or 2 drips. So can we... We had a bigger amplitude. We had more of a bigger wave, a higher, more discernible difference between the crest and the trough in each part of the wave. All right. All right, wait, just one more part. Part 3, adding a slit. Predict what you think will happen when you add a slit, then describe what happens when you add a slit with 1 and 2 drips. Okay. So, slits. Okay. And it wants us to drip, so it wants water. Okay. You look at this, what happens to this wave generator? You have a wave that's flowing in the water. Why does it change the wave when it has to go through a slit here? Yeah, absolutely. It does have to bend. Let's think of sound too. Sound we talked about a little bit yesterday. This is kind of like sound going through a doorway. Does it sound different, whatever you're listening to, when you're outside of your room rather than inside of your room? Yeah, because the waves are changed. They have to... Notice it's just this part of the wave right here that's actually going out into the room. But like we talked about with sound, is moving the air molecules. Ways. All right, so although we did not, we explored it a little bit. What do you think would happen if you were to complete this investigation with sound? How do you think that would affect what you would hear? Be specific on how changing the frequency, amplitude, and number of sources would alter what we would hear. So if you wanted to, you could go back with the sound button to the interference module, or the interference part of it, put it on sound, and see what happens. So if we separate them farther, put them together, we can see what those sound waves are going to do. All right, so after you think about it and write something on the conclusion, then you can submit that paper just as accountability that you did do that one. Okay.